بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Uh, these are some exercises about section 1.2. Here we have f of x is a function and h is not 0. And the question, does f of 3 plus 2 equals f of 3 plus 2? Well, let us find out. Now 3 plus 2 here is 5. So f of 3 plus 2 is actually f of 5. If we find f of 5, we replace here, or to find f of 5, we replace x by 5. So I have 3 times 5 squared minus 6 times 5. Well, this would be 3 times 25, which is 75, minus 30. 5 times 6 is 30, and then the answer is 45. So this is f of 5. Let us now find f of 3 plus 2. f of 3 plus 2, so this 2 is not inside the function f. It is not in the domain. It is not in the one of the inputs of f. So I find f of 3 and I add 2 to it. So what is f of 3? I replace x by 3 minus 6 times 3. So this is f of 3, and then I add 2. So this is the difference when we write 2 inside or outside. So here 3 square would be 9 times 3, this is 27, minus 18 plus 2. And when you add 27 minus 18 plus 2, the answer is 11. So actually, if no, the answer here is no, they are not equal, they are different than each other. Find f of x plus h. To find f of x plus h, I just replace x in this definition by x plus h. So I will have 3 times. Now I write x plus h instead of x, and I raise it to the power 2. I have another x in the question, so I also replace it by x plus h. And now you just need to expand or simplify. Remember, this is x plus h squared, so it is x squared plus 2hx plus h squared. This is how we square a binomial. And expand, minus 6 times x and minus 6 times h. So I have 3x squared plus 3 times 2, 6hx plus 3h squared minus 6x minus 6h. Now a question, does f of x plus h equals f of x plus h? Well, we know now that the answer is no, but to prove it, let us find f of x plus h. So we found this. We replaced x by x plus h here. But for this one, I just find f of x and I add h to it. So I have f of x already. It's 3x squared minus 6x. So 3x squared minus 6x. This is f of x. And then I write it plus h. So this would be f of x plus h. It is not equal to f of x plus h, the one we found here. So this is f of x plus h, but this is f of x plus h from outside. This is from inside, this is from outside. So they are different, and there is a big difference between when you put h inside parentheses or outside. This will make a huge difference. Okay, does these two equal? Also, this is not, because this is different than this. Anyway, to check, I will find f of x plus f of h. We have f of x, which is 3x squared minus 6x. And how do we find f of h? We replace x by h. So we will have 3h squared minus 6h. So this is f of x plus f of h. But this is not equal again to f of x plus h because this is f of x plus h. Okay, it has 3x square. I have 3x square here. Minus 6x is here and here. 3h square also here and here. But this term now, which is 6hx, does not appear here. So they are not equal. F of x plus f of h is not equal to f of x plus h. Find this quantity. This quantity is called the difference quotient and simplify. All right, I have f of x plus h, which is this one. So I will write it 3x squared plus 6hx plus 3h squared minus 6x minus 6h. This is f of x plus h minus f of x. What is f of x? 3x squared minus 6x. By definition, this is f of x, 3x squared minus 6x. All of this over h. So I have 3x squared plus 6hx plus 3h squared minus 6x minus 6h. And now I expand. I remove these parentheses. Minus 3x squared and minus times minus is plus 6x. All of this over h. Now notice that 3x squared minus 3x squared cancels and 6x minus 6x minus 6x plus 6x cancels, and I have these three terms. Look carefully to these three terms. I can take h as a common factor from all of them. So if you take h as a common factor from the first one, you have 6x, then plus. If you take h as a common factor from here, you have 3h. Actually, you divide 3h squared by h. Then you get 3h, and minus 6h divided by h is just minus 6 over h. Now you can cancel h with h, and the final answer would be 6x plus 3h minus 6. So this is the difference quotient in this case. Question 23. The graph of y equals x squared minus 4x is shown below. So it's a parabola, as you can see. Whenever you have a quadratic equation, x squared, ax squared plus bx plus c, the graph is a parabola. What are the coordinates of the point Q? Well, this is the point Q. To find the coordinates of the point Q, it has x coordinates and y coordinates. Well, the x coordinates, I go to the x-axis, perpendicular line to the x-axis, I reach this number, which is 1. So the x coordinate of Q is 1. The y coordinate of Q is negative 3. So the coordinates of Q are 1 and negative 3. Do they satisfy the equation? They must satisfy the equation because Q is a point on the parabola. But let us check. Y, which is negative 3, this is Y, should equal to x squared. X is 1. So 1 squared minus 4 times x, which is 1, which means the negative 3 equals 1 minus 4, which is negative 3. So yes, it satisfies the equation. Negative 3 equals negative 3. What are the coordinates of R? Let us see. Where is R? This is R. Okay, this is the point R. To find the x coordinates, I go to the x-axis. So the x coordinate of R is 3. This is the point R. And the y coordinate also same as Q, which is negative 3. So this is the point R. Do they satisfy the equation? Yes, they must, because R is also a point on the parabola. But let us check. R is negative 3. Is it equal to x squared? Now x squared 3 square minus 4x. So 4 times 3, which is x. Now 3 square is 9 minus 12, and 9 minus 12 is negative 3. So negative 3 equals to negative 3. So it satisfies the equation. If the coordinates of the point B, P on the graph are AB, how are A and B related? So this is the point P and it has coordinates AB. How are A and B related? Well, A and B is a point on the parabola. So it satisfies the equation of the parabola. So X is A and Y is B. So B should be the Y of A. So B should be f of A. So it should be equal to a square minus 4a. So this is how a and b are related. Okay, b is a square minus 4a. What are the x values of the points on the graph whose y coordinates are 0? Okay, y coordinates are 0. If y is 0, here y is 0. So we are looking to the points on this line, the x-axis. So this point here, at this point y is 0, and this point y is 0. So what is the x coordinate here? It is 0. And y, what is the x coordinate here? It is 4. So the answer, what are the x values? 0 and 4. These are the x values of the points with y coordinates 0. Are these x values solutions to this equation? Well, they lie on the curve, on the parabola. So yes, they are solutions, of course. Yes. And we can check that by replacing x by 0. So 0 square minus 4 times 0 will give you 0. That's correct. And if you put 4 square minus 4 times 4, this would be 16 minus 16, which is actually 0. So yes, they will satisfy the solution, the equation. State the domain and the range of each function in these problems. So here this is an equation without a square root, without a denominator. So the domain is from negative infinity to infinity, and the range also is from negative infinity to infinity because it's a straight line. So y could be, it is not a straight line, sorry. This is not a straight line. So the range here is not from zero, from negative infinity to infinity. Well, we have a rule or a formula to find the domain always. As we mentioned, if you have a square root, x plus 4 should be greater than or equal to 0. So x should be greater than or equal to negative 4. So the domain is from negative 4 to infinity. But to find the range, usually we need to sketch the graph of the function. Okay. So if you sketch the graph of the function, that's the best way to find the range of the function. Here, to find the domain, x squared plus 1 should be greater than or equal to 0. But actually, this is x squared. It's always positive, and you are adding 1. So this is always correct. This is always correct. Always true, this inequality. So the solution of this inequality would be all real numbers. So the domain here of this function would be all real numbers. For the range, remember you need to graph. So the graph of this uh, equation is a parabola up 4 units up, taken 4 units up. So actually the range here is from 4 to infinity. While here, this is a square root 4 units to the left. So the graph is the same as the square root. So the graph of this equation, if you like, a parabola taken 4 units up. So it's like this. So you can see that the range is from 4 to infinity. The range for this function is from 0 to infinity because the graph is like this: 1, 2, 3, 4, 4 units to the left, and the graph is the square root. While here, this is x squared plus 1. The graph here is not easy to graph, to sketch the graph. But if you look to the values of y, if you replace x by any value, then we will always have a square root of a number. So y is positive. I can find out that y here is positive. But it is not only positive, the smallest value of x is 0. So 0 plus 1 is 1. So the smallest value of y is actually 1. Okay, so y is in fact greater than or equal to 1, not just 0. So the range of this function would be from 1 to infinity. So you have these two methods: either you sketch the graph to find the range, or you put the values of x and figure out what would be the values of y. How to find f plus g? Well, this is f of x plus g of x, and this is f of x minus g of x, and this is f of x times g of x, and this is f of x over g of x. So for example, in question 35, f plus g of x would be equal to square root of 2x plus x squared. And f minus g of x would be square root of 2x minus x squared. And f times g of x would be square root of 2x times x squared. And f over g of x would be square root of 2x over x squared. That's it. Now find f circle g. Well, by definition, if you remember, f circle g is f of g of x. Here, g of f of x. And this is f of x already defined, which is f circle f. And f square here, this is a new definition for us. F square means f times f of x, which is f of x times f of x. So A would be f circle g, f of g of x, which is f of, you put g of x, which is x to the power 4 plus 5, and you go to f and replace x by this. So it would be 2 times square root of x to the power 4 plus 5. To find b, we need to find g of f of x. So we write g first, and we put the definition of f of x, which is 2 square root of x. And then we go to g and replace x by 2 square root of x. So we will have 2 square root of x raised to the power 4 plus 5. 2 to the power 4 is 16. Square root of x to the power 4 is x square plus 5. Now, see f of x. We write f and we put the definition of f of x, which is 2 square root of x. And then to find f of 2 square root of x, we replace x by 2 square root of x. So we have 2 square root, and we replace x by 2 square root of x. So this would be the solution of part C. Finally, f square x would be f of x times f of x, which is 2 times 2, 4, and square root of x times square root of x will give you x. Uh, Question 40, another question, okay? So we need to find all of these four. So let us start by a, which is f of g of x. It is f of 4x plus 1, and it would be 1 over 4x plus 1 to the power 3. B, we need to find g of f of x. It is g of 1 over x cube, and it is 4 times 1 over x cube plus 1. So I can write it 4 over x cube plus 1. C, I need to find f of x. So it is f of x, which is f of 1 over x cube. So it is 1 over 1 over x cube. To simplify this, I write it 1 divided by 1 over x cube, which is 1 times the reciprocal of this, which is x cube. So the answer is x cube. Finally, f square of x, this is as we mentioned, f of x, which is 1 over x cube, times f of x, which is 1 over x cube. If you multiply these two fractions, 1 times 1 is 1, and x cube times x cube is just x to the power 6. You add the powers. This is the end of these exercises. Study hard and take care.